And the first equation we're going to deal with is a multiplication equation. If it's a multiplication equation, what property am I going to use? The division property. Now, do you guys notice on my notes, if you remember on Friday or if you look at them, do you remember for addition equations, which property do you use? Subtraction property. For subtraction equations, you use addition property. So you see how these are inverse operations? This is what I put up on my board here to help you out. Addition and subtraction undo one another. If you add a number and then subtract that same number, you start off where you were at the very beginning. And same thing with multiplication division. And to test this out, let's see here. Eva, give me a number. 4. Okay, I'm going to start off with 4, right? If I add 7, how do I undo that adding of 7? How do I go back to 4? I subtract 7. What happens with the 7 minus 7? What do I get? 0. And what's 4 plus 0? 4. So that got rid of it. If I stay with my 4, and instead this time I subtract 3, what undoes that subtraction of 3? Adding 3, because negative 3 plus 3 is worth 0. And what's 4 plus 0? 4. Do you see how I get my original number? So we say addition and subtraction undo each other. Mr. A, does multiplication division work that way? Yes. Absolutely. Give me a number, Matthew. 3. Sorry? 3. Okay, let's start with 3. What if I multiply that by 4? What's going to undo the multiplication of 4? Dividing by 4, because what's 4 over 4? Ooh. What's 4 over 4? 1. And what's 3 times 1?
3.
Anyone see it yet? I've been using 2 properties. I've been using, for the addition subtraction properties, I've been using this property. And now for this one I use the same property, different way. Darius? Identity property. Just identity. And then inverse, kind of. Yeah, I could see inverse, but definitely identity. Ma'am?
So are you just trying to find, are you just trying to make it 3?
Yes. And you're like, Mr. A, I'm tired of this. Stop doing this stuff because I don't see what the point is. Ready? If x is being multiplied by, let's go with 4. If x is being multiplied by 4, what undoes that multiplication of 4? Divide by 4, because 4 over 4 is 1, and x times 1 is, interesting. Okay, who can read this for me, right? This little statement. If, Lana?
If A equals B, then A over C equals B over C.
That's the division property of equality. Can somebody tell me what this is, A equals B? What is that called? It's a mathematical statement called, it's specifically a, Alex? Equation, right? Because it has what symbol in there? Equal sign. So it's automatically equation. Now, who did I have in this class? Was it Philip and William, right? Remember I had you guys on both sides here? Now, I wanted to illustrate this property, but it's really hard to do. I wanted to say, well, what if I divide them by 2? I can't do that, guys. I'm not be weird or very bad. I tried it one time, didn't work. So if I had 4 books, on each side, what happens with my scale? I'm balanced. I'm even, right? What if I divided 4 by 2 here? What am I left with? 2. What if I divided this by 2 as well? 2. So what do I have? A balance or an equal scale there. Okay, that's what we're saying. If you divide both sides by a same number, still equal to one another. Let's look at our first equation. 4x equals 172. Yeah, hold off on working out because here's what I said to the other class. And I'm saying this, I hopefully out of my job for you guys, I have 60 things I want to do this year. And we're like on number, 8. One of my jobs is to make you realize I'm trying to prep you up for the future. So I want you to do well today. I want you to do well in your quiz and your tests. But I want you to do well not only in pre-algebra, but algebra 1, and then geometry, and then algebra 2, And then what comes after that? Pre-calc. And then after that? Calc or stats, statistics. I'm trying to prep you up for those things. All right. What's the variable? I mean, I'm going to start this off here. X, right? So that's an unknown number. I don't know what that number is off the top of my head just by looking at it. Do you guys see that there's a left side and there's a right side? And what do we know about those two sides? They are equal. They are balanced, right? We're balancing them out. We're going to keep them balanced the whole time. Okay, so what's happening to x? It's being multiplied. So I'm going to ask this simple question here. What type of equation is that? It's a multiplication equation. What do you use for a multiplication equation? The division property of equality. I'm going to divide both sides by 4. Both sides by 4. Because I don't want this. I want this. And so I require you guys to show me on both sides what's happening. And hopefully, Mr. I don't want to do it to both sides. Just do it. You'll get over it. It'll be fine. But what's 4 over 4? 1. What's 1 times x? X. What property is that? Identity property of multiplication. Very good. So do we use the properties, by the way? Do we use them a lot? One of my goals, number 17, is to make you like the properties. And some of you are like, Mr. A, I hate the properties. So man, I got a hard task. But here's what my point is. You do like them. Some of you just really don't know it. You use them all the time. And if you didn't use them, then you would really hate math. This property right here makes my math easier. 4 over 4 is equal to 1. 1 times x is x. We're good. Now it's 172 divided by 4. And what's that?
43.
43. X equals 43, or does it?
Yes.
Okay, all these problems can be checked. So, how do you check it, Mr. A? If I think x equals 43, then shouldn't 4 times 43 equal 172? Yes. 43 times 4, 12, 17. It equals 172, so are we good? Yep. Okay, is this the answer? Yes. Are you sure about it? Yes. I am very, very sure. I checked it. Okay, let's go here next. 18x equals negative 135. Okay, what kind of equation is this? Multiplication. What do you use for a multiplication equation? Division property of equality. The division property of equality. Okay, so what do I divide both sides by? Why not negative 135? I'm allowed to do that. I'm sitting right here in front of you saying I'm allowed to divide by 135 negative. Why 18 though? Yes, sir?
18 is multiplied by x.
So I want to undo what's happening to x. So what's happening to x? Multiplied by. So what do I divide both sides by? 18, because that undoes what was already happening. What's 18 over 18? 1. 1 times x? Good. I like properties. Thank you for that. Just plain old x. But what's negative 135 divided by 18? Positive or negative? Very nice. So really I'm just doing 135 divided by 18. 18 goes in 135?
5 times.
No.
7 times, but how many? What's 18 times 7? 1, 2. Oh man, it doesn't go into it evenly. So here you have two choices. Your answer can either be a decimal or it could be a fraction. Which one would you prefer? Awesome. Whatever you said is fine. It doesn't matter what you said. All right, 9. I get 7 and either 9/18, which reduces to what? Yeah, negative 7.5, or you would have gotten negative 7.5. Either one is good. You don't have to do both. You can just do one or the other, but make sure you simplify fractions. Mr. A, which one would you prefer? I don't care. Either one. Whatever's easiest for you. Now, the original problem was this right here, right? Did the original problem have a fraction in it? No. Did it have a decimal in it? So if it didn't have either one of those types of numbers, I can take either one of them for my answer. What if it had a fraction in the problem? Which one do I need to have up here? The fraction. What if it was a decimal up here? Decimal. What if it had both up here?
Doesn't matter.
Either one again. Yep. So you have choices sometimes, but a lot of times you have one or the other that you must get. Does it work? Is that really it? I don't know. So we check it. Which one would you check? Which number do you want to check? Your choice. All right, you'll do the decimal version. So let's see. 18 times 7.5. Now, notice I don't have the negative sign there. You know why I don't put the negative sign there? Because I already know it is going to be negative. Whatever it is negative. All right, 8 times. Okay, we'll just do this. 40, 9, 0, 56, 12, 0, 5, 3, 1. Decimal point. What do I get? Negative 135. Does this check? Is this the answer? Can you be sure of it? Oh, what happened here? Some of you, as you look at this problem, like, for many reasons, maybe, first, big number, right? That's kind of a big number. And then what's different between this problem and the other two problems? Yep.
There's negatives.
Okay, they're both negative, so now, oh man, which one are you going to deal with? And the n is over on the right side, so good luck. Is that, yeah, some of you are like, it's fine. Some of you, I hate the variable on the right, mister, I love it on the left. Fine. Can you make it go to the left? It's like this. William was here and Philip was here. Could I do this? Yeah. So I'm going to do that if you really prefer it. And that's your equation. Same thing. That's called the symmetric property. Are there a lot of properties in math? Yes. Are they good or bad? Oh, look at that. Mission 8 successful for some of you. Now, some of you probably still think, I hate them. No, you like them. You love them. You just don't know it. So my goal is to help you to know it. Okay, how do you know what to do in this problem? I know Darius knows. Henry, let me ask you this question. What type of equation is this?
Subtraction. Addition.
What's going on between n and multiplication? What property should I use? Natalie.
The division.
Division property. What should I divide both sides by? Sam.
12. Negative 12.
Good. Negative 12. Negative 12. Both sides. Mr. A, do you really have to write negative 12 on both sides? Yes. And I'm telling you right now. Okay. Notice we're dealing with what type of problems?
Negative. Equality.
And what do you call those? Equations, right? Equations. Are we always going to deal with equations?
Yes.
We're going to deal with inequalities. And in inequality problems, if you don't do it to both sides, there are certain problems where, Mr. A, I thought I'm doing it right, but I keep getting the wrong sign. What's wrong? Did you do it to both sides? Well, I don't like doing that. Okay, then don't complain about a wrong answer. Because dividing by a negative on an inequality changes the inequality itself. You think that's important to know? Yeah, that's next chapter, by the way. We'll get to that. What's negative 12 divided by negative 12? 1. Positive 1. What's 1 times n? N. Nice. All right, what's negative 4248 divided by negative 12? Positive or negative?
Positive.
Positive. And then something, I don't know. Drew knows? What is it?
354.
3. Yes, sir.
How I know if it's positive or negative, I just do 12, or it's the first one's negative, and the second number is negative. So I know it has to be a positive because a negative times a positive.
Yeah, see, and that you're almost doing like a check. A negative times a positive would be a negative. Mm-hmm. So you know this number right here has to be positive. Yeah, that's a good way. Is this the right answer, though?
Yes.
You sure about that? Jack, what is it?
Positive 354.
Mm-hmm. You doing okay back there? Okay. Sam?
Oh, I see it now. Okay.
Okay.
So like a negative divided by a negative is positive because it's 2.
2 negatives, yep.
So you still divide it out the same way. It's just positive.
Yeah, you'll just do, if you like, I didn't know what that was.
Because the only tricky thing is just subtracting, right? Because you have to keep change.
It could be, yeah, some people see subtraction as being tricky. Yep. Yeah, some people think division's weird, and that's fine. How many of you agree with 354? Okay, good. How many of you are pretty good with multiplication equations? Okay, I think you guys are doing pretty well with that. What about division equations? I don't think I even needed to write this down, to be honest.
Using the multiplication
Of equality, yes. Yes. And what is that multiplication property of equality? If A equals B, then what is going on in there? I don't know. Someone explain it to me after you're done writing it. Michelle, you'll do the honors. You'll explain what this means right here. Don't worry, I'll give you 30 seconds. Then you have more time. You're good. All right, if we have a division equation, which property should we use? Multiplication property of equality. Very nice. What is the multiplication property of equality? Michelle, what do you think? Do you want me to read it? If A equals B, then A times C is equal to B times C. Let me help you out with an illustration. Balance beam right here. I have one book on each side. What do I have? Balance, right? What if I multiply each side by 3? Should still be balanced. So, if I multiply both sides by the same number C, what happens to the equation? It stays balanced. Yep, that's all we're saying with the multiplication property of equality. Very nice. Here's our first one. A divided by 5 is equal to 24. What kind of equation is it?
division.
It's division, yeah. And I think some of you are thinking, I need to use multiplication, but what kind is it to start off with? It's division. What undoes division by 5? Multiplication by 5. Which sides? Both. Thank you, both. I'm going to multiply this side by 5 and multiply this side by 5. Am I allowed to do that, by the way? Can you just multiply both sides by 5? Yep. Absolutely. And the reason I did that is because maybe you're looking at what happens here. Do you guys know what happens with the 5s? They just become 1 over 1. What's 1 times A? A. What property was shown there? Identity property. Oh, man, the identity property again. Yeah, does it show its head on these problems? Every single problem. Everyone. Identity properties in it. Okay, but what's 24 times 5? 120. Are you sure that's the answer? How do you know if it's the right answer? Mr. Ray told me. My neighbor said the book had it. Which one is it? What's 120 divided by 5? 24. It checks. It has to be the right answer. Oops. Ignore this. What kind of equation is this? It's a division equation. What property should I use? Multiplication. What should I multiply by? 6. Okay, good. Yeah, it's being divided by 6, so I should multiply by 6. But there's something that could throw some of you off if you're not careful. These cancel out, right? What am I left with on the left side? Negative x. The x didn't just disappear. Sir?
I know how to solve it.
Okay, do you want to give me what's 37 times 6?
It's 222.
222, yep. 222.
But you can't have the negative x, so what you'll do is you take the x and you put the negative on in front of the 200.
So do you get like x equals negative 222? Okay. How many of you are in agreement with that? If you have negative x equals that, you should have positive x equals the opposite. Which property was used?
Inverse.
Because of what? I'll let you see if you can do that.
Inverse of
Division.
No. There's no inverse of multiplication, but you could say it's inverse of multiplication, but it's not even that. this is what you did. In order to do this, and I didn't want to tell you Friday because it was what we're doing today. What's both sides times negative 1 going to give me? What's negative 1 times negative x?
Negative 222.
Positive x. What's 222 times negative 1? What property did I use when I multiply both sides by the same thing? Multiplication property of equality. You're using that property again to get this value. We're not just making things up is what I'm trying to say. So do I just write numbers on the board and hope you get it? Of course I do, sometimes. But on these problems, there is a process and there are properties that we use. Ma'am?
So would you do that for each time, like add the negative 1 to each side?
Or multiply both sides by negative 1. If you have a negative variable, yes.
Okay.
Yep. Yes, ma'am. Or sir. I'm struggling. You're not the first today. Sorry.
Negative 222 divided by 6 is not 37.
Great question. All right, ready? I'm going to check it, and the original was negative x over 6 equals 37, right? Okay. Remember, it says the negative x, which, what is negative also known as? Opposite of x. Okay, what was x? Negative 222. What's the opposite of negative 222? Positive 222 divided by 6 does get me 37, which is really cool, but you got to be careful. It's the opposite of whatever x was. Well, what was x? Negative 222.
Perfect example of like checking it.
Yeah, because you could get 222. It looks good, but it doesn't work according to this. You'd get negative 222 divided by 6, negative 37. Wait, that's not it. And can I ask you this question? Having a negative sign or a positive sign, does that make a difference? Some of you are like, yeah, that's good because you should be doing this, but really doesn't make a difference. Think about it. You're playing in a basketball game and you make it on the other basket, and that's 2 points.
On the other.
Oh wait, that's the opposite side, right? But it was a nice layup, dunk. It doesn't matter. You did the opposite of what you're supposed to do. So you think that's bad? Doing the opposite of what you're supposed to? Some of you are like, yeah, I don't think it matters. Okay, please. Okay, don't cheer for that. Whatever if that ever happens with us. Okay. Oh, I don't like this problem because we have what? Decimals? Now, here's the problem. Negative 47.46 equals negative 8.4t. So that's a variable t. What kind of equation is this? Multiplication. What do you do to a multiplication equation? Divide. Divide by what? What number? Negative 8.4. Because it's going to undo what's happening to t, and you do it to both sides. What's negative 8.4 divided by negative 8.4? 1. 1 times t? T, that's what I wanted by itself. And then, a negative decimal divided by a negative decimal is always going to give you what kind of sign? Positive. And then all you're doing is 4746 divided by 8.4. Do you just divide it that way? Nope. Okay, so the decimal goes in a new spot, and it's positive, so I'm not even worried about signs anymore. 84 goes into 474. 5 times, that's 420. 4, 5. Oh, man. 84 goes into 540. 6 times, what's that? I think it's 5. That makes more sense. 546. Okay, but sorry, 84 goes into 546 6 times. And what is that? 504 sounds good. Oh, look at that. 84 goes into 420. 5 times evenly. You're done with that problem. What's my final answer? T equals 5.65. But is that the answer? Okay, check it. Somebody, or actually all of you check it. Because I don't know. I'm just guessing now. So you're looking at the board, you're like, no, check it. That means, is negative 8.4 times 5.65 equal to negative 47.46?
Yes.
Who checked it? That means you worked it out. Checked it? Anyone else? Is he the only one who's going to check it?
To check it, you would do 5.65 times.
Negative 8.4. Because I said t equals that. So I'm doing these two multiplied. And it should give me that, I hope. I really hope. Yeah. Let's see if some of you get the hint here. Let's see here. Good. 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 There you go. Good. 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 Sorry. Where's the word? You just check. You're saying what's 5.65 times 8.4? Good. 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 Okay, how many of you worked it out, 5.65 times negative 8.4, and you got negative 47.46?
Oh, no, I did not.
Yeah, you were off a little bit, but check your multiplication because I think that's all that happened. Okay, that's it. That has to be it.
I got a 0 at the end.
Yeah, that's okay. You can just drop that 0 out, and that's still the same number. Welcome to the final problem. The checking wrong? Okay, I'll work it out here and see if you guys can match it up. Now, if you're looking at this problem, you're probably like, what in the world just happened? I added a couple mixed numbers. But do you guys notice the variables over here? And does anyone know what to do with those two numbers? Yeah, I just add them up. These guys are two constants that I can combine together, and hopefully I can do something with that. What's 8 elevenths plus 3 elevenths? It's 11 elevenths. What's 12 plus 4? 16. What's 16 plus 1? 17 equals 5D. So I just combine, they're basically like terms. So how in the world do I solve this problem? Well, what's going on what kind of equation is this, Sam? What's going on between D and 5? It's multiplication. What do you do in multiplication problem, Alex? You divide both sides by what, Brad? 5 to keep it balanced. Now, did my problem have fractions or decimals? Fractions. So what kind of answer do I want? Fraction. So that's what I want. And so you're like, wait, that is a fraction, but it needs to be a mixed number form. So I get my Don't be scared of these problems, guys. Yeah, we throw some fractions and decimals, but fractions and decimals are just numbers.
Mr. If I check it with decimals, is that fine?
You can check with decimals. Like if you put 3.4 in here, 5 times 3.4 gives you 17. That should work. It has to work. But your final answer should be this, circled. Good question. Okay, I have a bonus part because we have a little bit of time. I have something I want to tell you that's going to fulfill number 17's goal. Okay, but do you have a question, Sam?
No, I'm good.
Okay, let me do this real quick here. Let me give you this problem. You're going to see this kind of problem, and I don't want you to be thrown off by it. Here we go. So write this on your paper. 1/5 R equals 5. 15, excuse me. 15, that makes more sense. All right. 1/5 R equals 15. What kind of equation is that? Multiplication? I'm good with that. What property should I use? I want to use the multiplication property. So can I ask you this? Am I allowed to do that? Am I allowed to multiply both sides by the same thing? Always. Always, always, always. Now, that doesn't always help, but let's see what I mean. Okay. Stay with me here, guys. I want to multiply both sides by the same thing, right? So I'm going to pick 5. Both sides by 5. Is that allowed? I'm just asking if it's allowed. Yes. Why would I do that? What's 5 over 1 times 1 over 5? What's 1 times r? 15 times 5? That's the answer. Did I tell you that multiplication and division are very closely linked? So instead of doing the division by 1/5, I multiply by 5. Mr. A, I hate math because you just tricked me or something. Sorry, I didn't mean to throw that so hard. I regret that sometimes, by the way, when I break them. Okay, let's do this here. How many of you that totally just went over your head? I hate that. Please go back. Okay, this is what I'm going to do for you. Guys, listen up. Last problem, then I'll give you your homework. You guys are correct to call this a multiplication equation. I'm good with that. So shouldn't you divide both sides by 1/5? Isn't that normally what we would do? What's 1/5 over 1/5? It's 1. 1 times r is... we'll pretend it's an r. Okay, that's 15 divided by 1/5. And you're like, what? 15 divided by 1/5. Stay, change, flip. Wait, what? Multiplication and division are so closely linked, I can interchange them. And that's what I did. It's amazing. I love it. By the way, when you multiply by 5 over 1, you know what property you use there? Inverse property. Because what's a number times its reciprocal? Always going to be 1. Ah, man, those properties. You got to love them. Sorry, you will love them.
But I don't.
Not yet. There's your homework.